In today's note, we're going to look at rearranging formulas. So this is the same idea as solving an equation, however, we're rearranging it without plugging any numbers in. We're still going to use the same ideas of balancing and opposite operations and isolating for a certain variable, except we're just going to be doing it without numbers at first. So for the first example, we want to solve the formula P equals 2L plus 2W for W. So what that means is we want to isolate W. We want to get W by itself to see what it equals. We've done this in the past where we've plugged numbers in and had to find W, except now we're doing it without plugging any other numbers in. So P equals 2L plus 2W, and we're going to treat it the same way. I want to get rid of this 2L, so I'm going to minus 2L. And I have to minus 2L from both sides. P minus 2L will equal 2W, because those 2L's will cancel out. And to get W by itself, because it's 2 times W, I need to divide by 2. And I need to divide everything on the other side by 2 as well to balance it out. The one side will cancel out, and I'm left with P minus 2L divided by 2 equals W, which is my final answer. So I've isolated for W. Now if I was given the information, I could plug it in and then solve for W. If I want to solve the following formula for B, again, the same idea. I need to isolate for B. So I have A equals B times H divided by 2. First thing I want to do is get rid of that fraction, so I'm going to multiply both sides by 2. The one side, it'll cancel out. I'm left with 2A equals B times H. To get B by itself, because I'm multiplying by H, I need to divide by H, and I'm going to divide both sides by H. And then I'm left with B equals 2A divided by H. Again, we've done a similar example with actual numbers in there, so now we're just doing one without plugging any numbers in first. For C, this one is going to be a little bit trickier, but we can still work through it in the same way. We're isolating or we're solving for T, so I have A equals P, 1 plus RT. If I want to get rid of multiplying by P first, I need to divide everything by P. I'm going to do the same thing to the other side. One side will cancel out. I'm left with A over P is equal to 1 plus RT. If I want to cancel out the 1, I need to subtract 1 and subtract 1 from both sides. So that leaves me with A over P minus 1 equals RT. And then finally, I'll bring this up here. If I want to get rid of, or I want to get T by itself, I need to divide everything by R. So I'm just going to rewrite my last line. But if I want to get T by itself, I need to divide everything by R. I need to divide everything by R on the other side as well. It'll cancel out on one side, and I'm left with A over PR minus 1 over R equals T. So it does look complicated, but again, we've done similar things where we've plugged numbers in or we've had actual numbers in. The reason that we do something like this is that it may be easier to come up with a new equation rather than have to plug in every single time and then solve and rearrange. For example, in number 2, the formula V equals D over T relates the speed V to the distance D and the time T. So we want to solve this formula for T. So say we want to come up with a new formula to solve for time rather than plug everything in and then rearrange. So V equals D over T, let's just rewrite that. If I want to get T by itself, T is on the bottom as a fraction. We don't like fractions, so we want to multiply everything by T. It'll cancel out on the one side. I'm left with TV equals D. I still want to get t by itself, so I need to divide everything by v. It'll cancel out on the one side, and I'm left with t equals d over v, which is our final formula. So we could use that formula anytime we want to find the time in this scenario. For b, now we're given some specific information. We're told the speed is 80 kilometers an hour, and we're told the distance is 280 kilometers, and we want to figure out what is the time. So in this case, I have my time formula, t equals d over v, and now I can just plug in my information. 280 kilometers divided by 80 kilometers per hour equals 3.5 hours. So I go through and solve that. Now again, the other way that we would have done that originally, we have v equals d over t. We plug everything in. We know the speed is 80 equals 280 over t, and then we would have to solve for t. Right? So if we want to get rid of the fraction, we multiply both sides by t. One side cancels out. We're left with t times 80 equals 280, and then we get t equals 280 divided by 80, and we get t equals 3.5. So this would be the way that we would do it originally, but if I have to constantly find the time, then it's just much easier if I come up with an actual equation, like we did over here, to use every single time, because it's much easier just to plug the two numbers in rather than have to rearrange the formula every single time. For example 3, same idea. We're given a formula for interest, I equals PRT, where we're talking about the interest I to the principal P, or initial value, the interest rate R, and the time t. So we want to solve this equation, I equals PRT, for P, which means we want to isolate P. So in order to do that, let's just rewrite our formula, I equals PRT. I want to get P by itself. I see that P is being multiplied by R and T, so the nice thing about that is I can group those together. If I'm multiplying by R and T and I want to cancel it out, then I'm going to divide by R and T. And I'm going to do the same thing to the other side. It'll cancel out on the one side, so I'm left with I over RT is equal to P, which is my new formula. Now, in the next part, if we're told what the interest is, we're told what the interest rate is, and we're told what the time is, and we want to solve for what is the principal, now we can do that rather than plugging everything in and then solving for it. So we have our formula, P equals I over RT. I don't know what my principal is, but I know my interest is 3,750 divided by my rate. Now the key thing we want to know about this, because we're dealing with percents, we want to turn that into a decimal. So we have 5% divided by 100 equals 0.05. So that is actually what our rate is. So R 0.05 times 10, we get 3,750 divided by 0.5. So we get 7,000. Oh, no, not 7,000. So when we divide those two, we get 75,000. Or sorry, 7,500. So that means our principal is 7,500. So again, this is a much easier way to do it rather than if we had I equals PRT and we had to plug in all of our information. Like such, and then have to solve and rearrange this formula. Right? So if I rearrange this, 0.05 times 10, So basically we're just doing the same thing that we would have done originally, right? We want to get p by itself, so we're dividing both sides by 0.05 times 10, do it to the other side, so then we get p equals 3,750 divided by 0.5, we get p equals 75 or 7,500. So if we know that we always have to solve for p, or that's something that we could be doing constantly, it's much easier to come up with a new formula rather than plug it into the original one and then rearrange every single time, because it can get complicated once we start adding numbers into it. So that's just the key thing that we want to look at with this note, is just rearranging formulas before we plug in any information.